Alright everybody, welcome back. This is our second video. We're going to be taking a look at finishing up the rest of these notes. Okay, we'll see how far we can get. So for part D, you can multiply numbers together. So 5 times negative 2 gives me negative 10. And because I'm doing x to the 4th times x squared, I'm adding the exponents. 4 and 2 gives me 6. Y to the negative 3rd times y to the 4th, add them. Negative 3 plus 4 gives me 1. And then z squared times z to the negative 1. 2 plus negative 1 is just 1. Boom. I have no negative exponents. All of my variables are combined together. We are in good shape. I'm going to skip over to f, and I will be jumping around a little bit here as we go on. Certain problems I may skip. X to the positive third, y negative third over x negative 1, y squared. We are taking your top exponent minusing your bottom one. So I'm doing 3 minus negative 1, and then I'm doing negative 3 minus 2. Well, if I clean that up, 3 minus negative 1 becomes 4. Negative 3 minus 2 becomes negative 5. Okay, this is going to take us a little while to get used to. But if it's a negative exponent, I have to flip it. So the x to the 4th stays up top, the y to the 5th goes down low. There we go. Okay? So just keep that in mind. Alright, negative exponent we flip. Alright, we're going to do part G. So this 3, the exponent, all these problems here, the exponent goes to every single term. And so does the 2. Okay, so up top, I get 3 to the 3rd, negative 1 times 3, a power raised to a power, you multiply, a to the negative 3, b to the negative 6, c to the 12, up top. Down low, 2 to the 2nd power, I'm just distributing the 2, multiply, a to the negative 2, b to the 4th, c to the negative 6. Okay. Cross this one off because I need a little bit more room. 3 to the 3rd power is 27. 3 times 3 times 3. And then on the bottom we have 2 to the 2nd, which is 4. So look what I'm going to do here. Top minus bottom. Negative 3 minus negative 2. Since minus negative becomes plus. Negative 3 plus 2 is negative 1. Negative 6 minus 4, negative 10. And then 12 minus negative 6 becomes plus 6, 18. So only the things with the negative exponents we flip. So the a to the negative 1, the b to the negative 10, they flip. Okay? It becomes positive after you flip it. Very good problem. This is a difficult problem. Please, as you look at that, don't get too sad or whatever. It'll be okay. Alright. Finally, in part I just wanted to bring this up again. We brought it up earlier. Anything raised to 0 power is always 1. Important little mathematical concept to keep in the back pocket for later use. Okay. So that wraps up properties of exponents. We're going to take a look at now a little bit more things with square roots, and then we'll kind of roll from there. When multiplying roots, multiply what is outside the radical sign than what is under it. So finally simplify. 3 root 5 times 2 root 10. Okay? You can multiply the 3 and the 2 together to get 6, the 5 and the 10 together to get root 50. And then they show this example down here. They broke down root 50 to be root 25 times root 2. The root 25 becomes 5. Multiply these together. Boom, you got it. So let me give you guys a really simple example. 2 root 3 times 4 root 2. 2 times 4 gives me 8. The root 3 times the root 2 gives me root 6. I multiply. Okay? That's all we're doing there. When dividing roots, simplify the numerator and the denominator. Finally rationalize if necessary. This is really nice, and it will help you guys out immensely. Square root of 32 over 50. 2 can go into both of them. So what you can do is break it up. 2 times 16 gives me 32. 2 times 25 gives me 50. Cross the 2's off. Now I have square root of 16 over square root of 25, 4 over 5. Okay? So let's try this. 18 over, let's go 72. I'll keep it simple. One number can go into 18 as well as 72. Well, 2 can. All right. Also 9 could work too. So let's go root 2. Take a root 2 out. Root 2 times root 9. Root 2 times 36. Can you guys see that the 2's cancel out? Good. What's the square root of 9? 3. Square root of 36? 6. And that can reduce down to 1/2. Alright? Just some easy simplification. Here are a few other problems as well for you guys. This is going off of this page right here, so it's the second page that I'm going to hand out to you guys in class. This is called rationalizing denominator. So let's just take a look at this real quick. And I'm going to show you another, well, show you this one. Root 5 over 12. We can break this down. Root 5 over root 3 times root 4. So the square root of 4 becomes 2. Alright. As I mentioned to you guys before, negative exponents are ugly. We don't want them. The same thing goes when you have a square root and denominator. That is bad. Okay? So we do something called rationalizing denominator. You find the square root in the denominator and you multiply top and bottom by it. Okay? So root 3 over root 3, this gives me 1. If I multiply up top, I get root 15. Square root of 3 times square root of 3 is root 9. Square root of 9 is 3. Clean that up, you're all set. Just take a look at this with me real quick so I can show you a better example. 1 over square root of 2. To rationalize this, you figure out what's the square root in the denominator and multiply top and bottom by it. So up top, 1 times root 2 is root 2. Down low, root 2 times root 2 is root 4, which will turn into just regular old 2. Okay? So the whole trick is that we're always trying to get rid of the square root denominator. We will get tons of practice with this. You guys will be in great shape for it. Okay, last one here. Let's see here. When adding or subtracting roots, simplify first. If necessary, then you may add or subtract the coefficients of the like radicals. Like radicals have the same radicand, the value under the radical sign. So just a quick little side example here. Root 3 and root 3x are not like radicals. They have to be exactly the same for it to work. So here's my example. 2 root 3 minus 5 root 3. What you can basically do is the root 3's almost act like x's. So if I would have asked you guys what's 2x minus 5x, hopefully you guys are cool with it being negative 3x. Well, the same thing works with square root of 3. 2 minus 5 gives me negative 3 root 3. You might run into some problems where you simplify these down first. So I break down root 50, break down root 32. I get the same square root of 2. Add them out front, 9 root 2. So here's a quick example. 7 square root of 3 plus 5 square root of 3. Because they are exactly the same square root of 3 right here, add the numbers out front. 7 plus 5, 12, root 3. Alright? Awesome. Okay, down here, take a look at a few of these. Simplify the radicals. No perfect squares and no radicals in the denominator. Square root of 125 plus root 5. So I'm going to break this down. Okay? Square root of 125, I know that 25 can go into it 5 times. Alright, what's the square root of 25? 5. Okay, technically, what number's out here even though it's not written? Just a 1. Okay? So the 5 root 5 plus 1 root 5, grand total I have 6 root 5s. We're all set. Good. Alright, part B, square root of 3 over square root of 21. What number can go into root 3? What number can go into 3 and 21? Hopefully everyone's cool with dividing top and bottom by 3. So I get square root of 1 up top, square root of 7 down low. All I did was divide 3 by 3 and divide 21 by 3. Square root of 1 is 1, and that stays root 7. Okay, no square roots and denominator. Okay, so I'm going to multiply top and bottom by the square root of 7. So up top, 1 times root 7 is root 7. Down low, root 7 times root 7 is root 49. But that's nice because that turns into just plain old 7. Okay? Very good. So I'll tell you what, there's a little bit more to go, not a whole lot. Okay, a few more problems, and then we're all wrapped up. I'm going to save that for the next video. Okay? So we're going to pause right here, take a deep breath, and then we will get you guys back here ready to go. All right, as always, keep the good work and good luck. We are all counting on you.